All right, we're going to go ahead and take a look at solving single trig functions, or solving equations involving single trig functions. So it gives you some hints up there, but I think let's just go ahead and look at the examples, and then you can go back and take a look at those ones. But those are some tips and tricks for you from our textbook. Okay, so let's go ahead and take a look down here. So on this first one, it says find the exact solutions of the equation, similar to what we did in 6.1, and then list those solutions that are in the intervals. So we're going to do both things. So as we did in the last section, if we want to find sine of 5x equals 0 and we want to solve for x, we're going to do arc sine. In this case, 5x equals arc sine of 0. Okay, so with that in mind, we're now going to say, okay, well, I would actually probably take a pause here and say, well, when is sine 0? I put a chart over here on the right, and we can see that sine of 0 is 0 when it's 0. So arc sine of 0 is equal to 0. This is a little different than last time because we left it in those terms, but now we're actually going to plug in the value. And then how often does that repeat? Well, you've got to recognize, usually we added 2 pi, but in this case it's at 0 and pi that sine is 0. So rather than adding 2 pi and doing two different ones, it's going to be easier for us to just say, hey, every pi k, right, where k is that integer. So then to solve for x, we're going to divide both sides by 5. So x equals 0 divided by 5 is still 0, but we can do 5k divided by 5. And that's all the exact solutions. If we want all the solutions that are in the interval 0 to 2 pi though, well, you know, if you plug in like k being an integer starting with 0, we got 0. And then we've got plug in 1, so we've got pi fifths. Then we plug in 2, so we got 2 pi fifths. And we plug in 3, we got 3 pi fifths. And we keep going until we get really, really close to 2 pi. At 2 pi would be 10 pi fifths, but we never actually reach 2 pi, right? That's got a parentheses, so we don't actually include that. So the last one is 9 pi. Oops, sorry about that. 9 pi fifths. So our exact answer is the one on the top, and the one below is all the answers in the interval 0 to 2 pi. Okay, let's go to the next one. I would start off the same way. We're saying 2x equals arc cotangent of negative square root of 3 over 3. Okay. As you look at your chart over on the right, cotangent is the square root of 3 over 3 at pi thirds. The problem is it's now negative. So rather than it being a positive pi thirds, you could look over here on the chart on the right. We're either going to be in the second or the fourth quadrant, right, for it to be negative. So you kind of have two options about how you want to write that, right? We could say, okay, well then, like let's just consider the second quadrant. Pi thirds as a reference angle will give us 2 pi thirds in that quadrant. So we could call this 2 pi thirds. So you could have used negative pi thirds. And then plus, you'll notice here that if I do like pi thirds, right, that's the same angle as negative pi thirds here. We just add another pi. So in this case, once again, or you can think about tangent repeats and cotangent repeats every pi, we can just add pi k. To get x all alone, though, we're going to have to divide by 2 on both sides. So we end up with x equals 2 divided by 2 will cancel, so we'll be left with pi thirds plus, and then pi divided by 2, so pi k halves. As for your exact ones, you may have to think about this a little bit, but x equals, if I put 0 in, I just get pi thirds. And then you kind of got to ask yourself, well, what's pi thirds plus, you know, pi halves? So think about making that common denominator of 6. So this is like 3 pi and 2 pi 6. So we get 5 pi 6. Then think about adding another half. So we end up at 4 pi thirds. We add another pi halves, and we end up with 11 pi 6. I realize that was a little quick, but I'll let you kind of take a moment, pause the video, add those fractions together. All right, let's look at the next one. The next one, same idea. We're saying 9x equals arc cosine of 9. you should notice an issue there. What's the issue? Cosine, or like you can think about the outputs of cosine are only between -1 and 1. So therefore, for arc cosine, your input should be between -1 and 1, and we're inputting 9. So therefore, this has no solution. There are no angles that will give us out a value of 9 for sine. Okay, next one. We're saying x plus 5 pi 6 equals arc cosine of 0. So you've got to ask yourself, we'll leave the left side the same, and ask yourself, when is cosine 0? Well, it's 0 at pi halves. This one, once again, like, it's at pi halves, but then it's also at negative pi halves, so it repeats every pi. So we can just do plus pi k. This time, though, rather than adding, we're going to subtract that 5 pi 6 from both sides. So this gives us 0. But you may have to think for a minute, like pi halves, plus that. So if I make this over 3, or 3 over 6, they have the common denominator, we end up with x equals negative 2 pi 6ths, which I'm actually going to simplify. So if I write negative 2 pi 6 here, that's the same as just negative pi thirds plus pi k. That's not influenced at all. I just add my constants together. So therefore, let's think about when I plug in values. When I plug in 0, I get negative pi thirds. I don't want that because that's not my interval, so let's plug in 1. Well, if I add, pi plus negative pi thirds, I end up with 2 pi thirds. And if I add another pi and think about adding 3 to the top, we're at 5 pi thirds. Okay, let's take a look. There's 2 more, and I'll take a pause before we solve the next part of the video. So, as we take a look at this next one, we're going to go ahead and do the same thing. So we get 2x minus pi thirds equals arc sine of negative a half. Okay, unfortunately with arc sine, notice we're going to be, wrong 2 quadrants, so it's positive. We're going to be in the 3rd and the 4th. So these ones, we don't have the fancy trick of just being able to add pi because they're not kind of opposite each other on the graph. So we're actually going to have 2 different equations. We're going to have 2x minus pi thirds equals, so if we think about a half, that's pi 6. So in the 4th quadrant, I'm just going to call that negative pi 6 plus 2 pi k. And if I'm in the 3rd quadrant, that's 1 more than pi, or 1/6 more than pi. So therefore, I'm going to be 2x minus pi thirds equals 7 pi 6 plus 2 pi k. Okay, think about solving for x. So you want to add pi thirds to both sides. And if I really want to make this out of 6, I'm going to make that 2 out of 6, right? So we end up with 2x equals pi 6 plus 2 pi k. Think about dividing both sides by 2. So x here equals pi 12ths plus pi k. Do the same thing on this side. So we're adding that pi thirds, but we know that's the same as 2 pi 6. So we get 9 pi 6 plus 2 pi k. Divide this all by 2. So we get that x equals 9 pi 12ths, but you could simplify, right? If I wanted to get 3 out of both of those, I'd have 3 over 4, so let's write it that way. You'd have 3 pi fourths plus 2 pi k. Okay, if I wanted to now think about what that would be in our interval, we'd have x equals over here pi 12ths. And if I add another pi, I'd be at 13 pi 12ths. And if I add another pi after that, I'm out of my interval of 2 pi. So let's go over here. We're at 3 pi fourths. If I add another pi to that, think about adding 4 to the top, we're at 7 pi fourths. So we've got our exact solutions. And we've got the solutions on that interval of 0 to 2 pi. Okay, let's look at the next one. This one, we've got secant squared equals 4/3. So this one we got to start by taking the square root of both sides. So we get secant alone. So secant of x equals the square root of 4/3. I'm going to rewrite that as, what's the square root of 4? Well, that's 2, and the square root of 3 is the square root of 3. This is the thing you probably would forget if you're not careful. Whenever you take a square root, though, technically there's two different answers. And what are those two different answers? We get both a positive and a negative. So as we think about arc, letting x equal arc secant, like let's say positive 2 over the square root of 3, you also have x equals arc secant of negative 2 over the square root of 3. So really, it can be in any of the four quadrants because we don't care if it's positive or negative. So we just have to ask ourselves, well, with secant, that relates to sine, and so therefore we're talking about pi 6. Okay, so this could be x equals, in this case, positive pi 6, right? And it really can repeat every pi, so pi k. Or over here, it could be like your negative pi 6 to be in the fourth and second quadrant. Or you could call that 5 pi 6 plus pi k. And that will get us to all four quadrants. Okay, so now if we find the exact values and we plug in some numbers, we get x equals pi 6. We get 7 pi 6. As we do the 5 pi 6 and we add another pi, we end up at 11 pi 6.